Hi everyone, I'm Muhutan and my metric number is S77569 and today I'm going to present my individual assessment. So in this part I'm going to explain from the data entries and to the final answer. So let's start with my question, and my question is from the chapter 13, correlation and linear regression. Let's continue with my question. So in my question, they asked me to refer to the Lincoln Wild School data and develop a regression equation that expresses the relationship between age of the bus and maintenance cost. The age of the bus is the independent variables. So these are the data we are going to use to input our data in the SPS software. So let's we continue with our SPS software because we are going to input our data which is given here in the Excel. So in this Excel, according to our question, we are mainly going to see is maintenance cost and age. So we are going to input the data in the SPSS software. So first of all, we are going to click the file, but we are going to input the data directly from the Excel to the SPS software. So click variable views and input the variables we need. First of all is age and second is maintenance cost. And enter. Then we need to see the data view. Here we can see age and maintenance cost. And we need to go back to our Excel to copy the data we need. Here I have for age we have 18 inputs. Copy, then paste. Okay, then we need to copy the maintenance cost also. So click the Excel, go to the maintenance cost and copy all the inputs from the maintenance cost. Then paste. So here you can see all the maintenance costs and the age variables. So first of all, we are going to create or draw a charted diagram. So we already input all the data we needed in the SPS software. So we are going to create this charted diagram. So click graph from above and click the legacy dialog, and here you can see the charted dot. Click the charted dot and click the simple charter. When you define, they will going to ask which one uh, is y axis and x axis. Y axis is the maintenance cost and x axis is the age. Then we are going to click OK. So here it can shows the diagram we created. Okay. So for the question B, we are going to develop a regression equation. How does an additional year add to the maintenance cost, and what is the estimated maintenance cost for a 10 years old bus? So we need to go back to the maintenance SPSS software, then going to click analysis and click regression and click linear. So here you can put the independent was maintenance cost and age as independent as was already given in the question. uh, for the confirmation, I can show you again. Here already mentioned the age of the bus is the independent variables. And then to the statistic, we need going to coincidence which is 95 level, and then we need to go into click all the model fit and R squared changes, destructive and parts and partial correlation, and continue and cancel and okay. So here it can given all the data from the regression, which is destructive statistic, correlation and variables entered, and then model summary and over and coefficient. Okay, so these are the data we are going to use the SPS software to input in the our individual report. So after we are done all the, get all the information from here, we are going to input all put all the information in our report. So in my report, I'm going to explain everything in detail by detail to you. For the first question, for the draw a static diagram, we asked to suggest what is the relationship between the two variables, and is it direct or indirect, or does it appear to be strong or weak? So as you can see the diagram, the setted plot of maintenance cost against the age of bus shows a clear upward trend and it illustrates positive and strong correlation relationship between bus age and maintenance cost. So it indicates that the age of element rating the cost of maintenance, one or more the other factors have to be significantly influencing the expenses of maintenance. And then we are going to see about the development a regression equation. We are continue with the coefficient. So here we can see the significant, which is less than 0.001, and then we also have to use the t-test statistic, which shows our t is equals to 8.843. So these are the formula we are used to identify, to do the regression equation, which is y equals to a plus bx. So the y is equals to the maintenance cost, and a is equals we are going to take, a is from the coefficient report, which is 337.297, plus with the b is 603 and 3.161, and x is equal to h. So the coefficient table contain all the information necessary to write the equation. So the interspeed is 337.297, which is expected maintenance cost for a bus with a 0 year of age, and the slope for age is 603.161, which is implying that the maintenance costs rise by roughly 603.16 of each extra year of bus age. The slope answer also given to the answer to the equation how much an additional year to the maintenance cost. To calculate the maintenance cost for the 10-year old bus, we put as the age equal to 10 in the equation maintenance cost. So we will get 6,368 dollar 0.91 cent. So, and lastly, we are going to conduct a test of hypothesis to determine whether the slope of regression line is greater than 0. So we can go to our answer, which is what I did was, so first of all, I'm going to in this question C, I explain the hypothesis, the test of hypothesis, and then lastly I interpret the part A, B, and C in a brief report. So as you can see, the step one, I state the noun, which is HO is B1 is less than 0, and H1 is B1 is more than 0, which is shows the slope of regression is non-negative, and H1 is the slope of the regression is line is positive. So as you can see from this question, I select the level of significance is 0.05, and then we are going to select the test statistic. So we have used the t value for the slope coefficient in the regression output, and from the coefficient table we will get the t is equal to 8.843. And then as a step 4, we're going to set up the decision rule. Has a degree of freedom n minus 2 and equal to, we will get 78, which is our n, total input is 80 and minus with 2, and we will get 78. So for the significant level is 0.5, so we will get 1.665 from the table when we are using the t-test statistic. So if t is more than 1.665, we will reject the HO, otherwise we do not reject the HO. And in the step 5, I take a sample and make the decision. As you can see, this is the formula to use this t statistic for the correlation efficiency formula. So which is give the R is equal to 0. Which is the regression is 0.708, and then the degree of freedom is 80 and degree of freedom is 78. So I'm calculate the t using the formulas, and I input all the data, the amount, figures in here. So you can see the answer step by step I explain, which is 8.832. So how did I get that? I explain it one by one in this section until I get the answer, and then we need to calculate the p-value. So with the t is equals to 8.857 means the df is equal to 78, then the p-value is less than 0.001. So according to the calculation, I did the making decision. Since compute t is more than 1.665, we reject the HO. And lastly, step 6 is interpret the result. We have evidence at the level of 0.05 level of significance to say that the slope of regression lane is greater than 0. Based on this, we conclude that bus H is positively and significantly related to maintenance cost. So here I also briefly report about part A, part B, and part C. So the charted plot shows a positive association between bus age and maintenance cost, suggesting that maintenance costs tend to increase with age of the bus. And part B, the regression of equation obtained was 337.297 plus with 603.161, and the x is h. So the predicted of the maintenance cost for the 10-year-old bus is $6,368.91. And for part C, we see from the result the test hypothesis has followed the slope of the regression line and is significantly different from zero. So this means that we have 90% sure that we are actually positive relation between bus age and maintenance cost in the population. Thank you.